Hello guys, we are on page 190 today, pretty much the same routine we've been doing all week. Just going to do a little bit of reading, no homework questions, hopefully have a little bit of a class discussion going on. Short class again today, so anyhow, that's kind of where we are. So enjoy, kick back. All right, now this is actually pretty cool right here, and that no pun intended. Because we are talking about ice and stuff. I know. I'm so witty sometimes that I surprise myself. Okay. Throughout the day, the temperature in the orange grove drops steadily. Okay. The anxious farmer waits to update weather forecast. The news is not good. Okay. They're expecting the temperature to fall even further during the night. And this does happen. Okay. The orange groves, if you ever notice, sometimes you go to a grocery store, there's an overabundance of oranges and they're fairly cheap. And then there's other years, there's not that many oranges because they did. Weather offset it and killed a bunch of them on the trees sometime. And the price goes up because the less there are, the more, more expensive they're going to become. So it's that give and take thing there, okay? So this does actually happen. So low temperatures could wipe out the entire crop. So he considers picking the crops early, but they're not ripe yet. So that's not going to work, okay? Instead, and they had these mesh pots that they would take out and try to warm up the area. Okay, and they would actually, it was all kinds of things that they attempted, but they soon figured out it was hard to heat the entire outdoors. It was hard to heat the entire outdoors. So instead, the farmer tells his workers to haul in hoses, and they actually spray the oranges down with water. And as the temperature drops, that water begins to freeze, and the ice actually keeps the oranges warm. How's that?
No, imagine you have ice and you melt off the...
We're back again to the thermal energy. This is what we've been talking about. Yes?
So the ice acts as like a shield to the oranges.
Basically.
It keeps all the heat in.
Keeps the heat in. Yeah.
It's like tinfoil a little bit. It keeps all the heat in.
Yeah.
So like the heat the orange has, it would like basically keep, it would stay inside the ice ball around it, but it would start melting the ice. That's why there's like the drips of water by the end of the night.
Absolutely. Okay. So, how can ice keep anything warm? Okay, the answer has to do with how thermal energy is transferred as water becomes ice. Okay, remember we've been talking about this off and on all week. Okay, so talking about states of matter. What happens when you hold an ice cube in your hand? Okay, it starts to melt. The solid and the liquid are both the same material, water. So water can exist in 3 different states, okay, or forms. In fact, most matter on Earth can exist in 3 states, and that's a solid, a liquid, and a gas. Okay? And although the chemical composition of matter remains the same, the arrangement of the particles is what makes the matter different from one state to another. Okay, that's what we have talked about this off and on all year. If something is solid, the particles are very close together. They're moving, but they can't pass each other. They become liquid, they get warmer, and they spread out, and now they can pass each other. The particles can pass each other. That's what makes them liquid. Gases, they spread out really, really far, and that's why they become a gas. They're not attracted to each other at all. Okay? Yes, Caleb?
Isn't gelatin a solid even though it jiggles?
Whoa!
Yeah, it is a solid.
It's a solid, it's just not as sturdy as a regular solid.
Yep. How about Jell-O? Is Jell-O a solid or a liquid? In its frozen state, if you would, it's a solid. Okay. But yeah. All right, the liquid, the particles that makes up a liquid are close together, but they are not held together as tightly as those in a solid. Okay, so they can pass each other. That's what makes them a liquid. Okay. A gas. Okay, in gases, the particles are moving so fast that they don't even stay close to each other. Okay? Gas expands to fill all the space available. And remember, they don't have a fixed shape or volume, just like liquid does not. Okay? Thing about a liquid, if you put water in a glass, it takes the shape of that glass. If you put it in a jug that is this wide, but this tall, it takes the shape of that jug. Gas is the same way, okay? If you put it inside a container, it takes the shape of that container. If you try to blow up this raft with air, which is a gas, then it takes the shape of that raft. Okay, in the picture there. So, some things actually has a shape, but something solid obviously has a shape to it. You're not going to change that unless you alter the makeup of the solid. Okay? All right. Changes of state. Okay? The physical change from one state of matter to another is called the change of state. I know all these scientific terms are going to freak you out, aren't they? It gets better, okay? The state of matter depends on the amount of thermal energy it has. The more thermal energy matter has, the faster its particles are moving, okay? Since a gas has more thermal energy than a liquid, the particles of a gas move faster than the particles of the same matter in a liquid state. Okay, that's why they're sort of spread out so far. Yes, Spears.
So would that mean that air is warmer than
Air is warmer. Think back in the beginning of the year, we took a paper towel, a brown paper towel, and we wet it, and we laid it out on the counter over there. Y'all remember that? And by the end of class, it was dry. And what's happened was the air went by and it warmed up and got those molecules in that towel to start moving faster. So as they moved faster, they became gas and they came up into the air, leaving the paper towel dry. That's how you dry clothes if you hang them out on a clothesline. It's not just the sun shining on them that dries them, it's actually the airflow. Sun doesn't hurt, but it's the airflow that is what actually dries them.
And the cool thing was that like it wasn't the ground, but the drawer in the cabinet, it wasn't wet after.
Yeah, exactly.
That was
Miller.
cool.
Sure. The important questions of the day. Okay? So, now then. Solid to liquid, changes of state, okay? This is another one that's going to shock you. Okay, a change of state from a solid to a liquid is called melting. I know. Those scientific terms are going to freak you out. Okay? Melting occurs when a solid absorbs thermal energy. As the thermal energy of the solid increases, the structure of its particles breaks down. The particles become freer to move around. And the temperature at which a solid changes, okay, here it is. When a solid changes to a liquid is called the melting point.
What?
I know, okay. The change, and it gets better. The change of state from a liquid to a solid is called freezing. Now, if freezing occurs when the matter releases thermal energy, the temperature at which matter changes from a liquid to a solid is called the freezing point.
The freezing point.
There you go. See there? See, this is tough stuff right here. Okay? Yet I could give a test on it, and half of us would go, what? Okay. All right. Yes, sir.
So, the less thermal energy it has, the more thermal energy it takes to change it into a liquid.
Yeah.
Because, anything can be changed, even steel, because when you heat it up real high,
Oh, anything, yeah. I mean, that cabinet back there is solid, and I think we can agree that's solid. If you expose that to a hot enough temperature, that would become a liquid. It would start to melt. Yeah, absolutely.
But yeah, the less thermal energy it has, the more thermal energy it takes.
Yeah, exactly. Yeah, exactly. Okay?
My mom works at Corning, and we went to the Corning Museum of Glass and we could watch the like mold glass and like melt it.
Oh, yeah.
And they made like little mini bears and like stuff. It was really cool.
Yep. Talking about molding glass, that's pretty cool to watch too. You have probably seen videos on it.
I've seen it.
Okay, yes, it is cool to watch. I've never seen it live and in person, but I take it back, I have. One time, just for a few minutes. Okay, liquid gas changes of state. The process by which material change from liquids to the gas state is called vaporization. Okay, during this process, particles of the liquid absorb thermal energy and moves faster. Eventually, they move fast enough to escape the liquid as gas particles. Okay, if vaporization takes place at the surface of a liquid, it is called evaporation. Okay, is a higher temperature, evaporation can occur below the surface of a liquid as well. Okay, this is called boiling. Okay, if you ever notice, you boil water, you get those gas bubbles. That water really starts to churn in there. Okay, and this temperature at which liquid boils is called the boiling point. I know. Yeah.
I just wanted to say one more thing. That
Oh,
if
if
you-
only.
if you melt a solid down and then you pour it out like that, that's how you make, that's how blacksmith make things.
Absolutely. You get it melt
Yeah.
down, then you put it into maybe a mold or something,
Well,
and
and
it
it's
takes.
so I don't know for sure, but is it just the air? Do they just let it sit out? Is that what?
A lot of times they'll put it in water, something like that. They put it down in cool water, and that cools it faster, and it takes the shape that it needs to take. Yeah. Okay. All right. When a gas loses a certain amount of thermal energy, it will change into a liquid. A change from the gas state to the liquid state is called condensation. Okay. You guys did weather, I know, at some point in time, so you should be familiar with all these terms. You have probably seen beads of water appear on the outside of a cold drinking glass. This occurs because water vapor that is present in the air, excuse me, loses thermal energy, which comes in contact with the cold glass. And back again, that's where the air is flowing by that glass, and because the air is warmer, okay, it starts to try to warm up that glass, so it starts hitting the glass, and because now it starts to get cooled down, it actually goes from a gas to a liquid. We will do this one day next week. We'll take a tin can and we'll put ice and salt in it and just set it over there, and we will watch what happens. It's pretty cool. You'll see water vapor in the air become liquid and then become a solid. Just on tin can, ice and salt. Yes.
So oh wait, whatever.
Whatever. This whatever.
It's just about glass blowing.
He acts like he's at home. He's back there. He's got his feet propped up.
But do I make good grades?
He just having a ball back there, man. Throwing out scientific terms like whatever. His mom's a science teacher too. Make her proud. All right. So we talked about evaporation, boiling, condensation, freezing, all kinds of really neat, wonderful stuff. Okay?
Why?
I wish this scanned the entire room for you guys so you could just see some of the stuff that was going on. It's really quite amazing at what happens in there. Of course, you know that. All right, thermal expansion. This is actually pretty good. Okay. If you ever loosened a tight jar lid by holding it under a steam of hot water, that does actually work. Okay. This works because the metal lid expands a little bit. Okay. Think about in the old days when they had the wooden wheels on the wagon, but they had the metal frame that the wood went on. They actually, the way they did it, they would put that on, and then they heated up the metal, and it expanded. And then when they cooled it down, it all came together nice and tight. And that's how they made the wheels. So you think about this, this is way back forever ago. They already had this knowledge. I mean, they didn't Google this. This is just, I mean, who figures this out? Okay, this is things that people just have experimented with throughout history and came up with a better way to do things. Not anything wrong with technology, don't misunderstand me. But people have existed forever without all of our modern technology and has gotten us where we are today. It's really pretty cool if you think about the things that the old people used to know, how they figured things out. I wonder sometimes if we were in that same shape right now, with all of our modern technology and with all of our education, could we survive the way those people did? You know, I mean, if you took away the technology, I don't think you could. I don't think we could. I think if we took away all the modern technology, people would be walking into walls. I think we'd just be completely buffaloed on what to do. For the most part, not everybody. Not everybody. Big cities would be hurting worse than country boys. But I think it would be interesting to, not that I want that to happen, because, you know, I like technology. Don't misunderstand. I'm lousy at it, but I appreciate it.
My mom says unless it's for school, I can play 30 minutes electronic throughout the week.
All right. Now, as thermal energy of matter increases, the particle spreads out, and the substance expands. With a few exceptions, this is true of all matter, even when the matter is not changing state. Okay? The expansion of material when it is heated is known as thermal expansion. And this is what makes your thermostat work, okay? In your home. When matter is cooled, thermal energy is released. The motion of that particle slows down and the particle moves closer together. In nearly all cases, as matter is cooled, it contracts or it decreases in volume. Heating regulating devices called thermostats uses a thermal expansion to work. Okay? Many thermostats contain a bimetallic strip, and these strips of two different metal joins together. Different metals will expand at different rates. So when this strip is heated up, one side expands more than the other. And this causes the strip to uncurl, and this movement of that strip operates a switch which turns your heat off and on. That's pretty cool if you think about it. That's pretty interesting. In my opinion, again, y'all might be sitting there going, I don't care. All I want to know is how to hit the button, and that's okay too. But I don't know. It's kind of cool to know how things work. At least I think so. Of course, that's why I'm a science teacher. Good to see you guys. Well, I didn't see you guys, but I know you love seeing me. So here's your opportunity. All right, we'll talk to you later. Enjoy your weekend. Actually, you're not going to get this till Monday, so I hope you enjoyed your weekend.